Hello everyone, welcome back to our channel. So, as I said earlier, today we are going to discuss about what are the expected long answer questions in the semester examination of mathematical analysis paper 1, which is same for both the courses, that is applied statistics and statistics. So, as we know there are 3 units, let us go one by one. And the first theorem is every neighborhood is an open set. Sometimes it might be asked for the short type question or a long type question, but this is the expected one. And this theorem, if a set is an open set, then its complement is closed set. If and only if, vice versa question. And this theorem, if x comma d is a metric space, then E is a subset of x, then E bar is closed set. E is equals to E bar, then E is closed set. These three might be asked for the long answer question. And the next theorem is every compact subset of a metric space is closed. This is the most repeated question from 2024, like 2024 and 2025 and backlog question papers also. And sometimes this question is also asked. Every closed subset of a compact set is compact. And this is the most repeated one. Every K cell is compact in R power K. And what are the questions that I am showing here? Most of them are long answer type. And previously shown are of the concept metric space. And these are now continuity and compactness. The both concepts are from unit 1 only. And this is the first theorem. Suppose F is continuous mapping of a compact metric space X into a metric space Y, then F of X is compact. And the theorem 7, it has came in 2025 question paper. And theorem 8, it is also repeated in 2025. And intermediate mean value theorem. And that's it from the unit 1. Now let us see the unit 2. Unit 2 is of Riemann's strategal integrals. In unit 2, in order to understand the theorems, first you need to be able to understand the definitions, the introduction part very clearly, so that you can easily understand and write the answers, write the theorems without by adding it. And the first theorem, it is for the long answer type question. That is L of P comma F comma alpha is less than or equals to L of P2 comma F comma alpha. This is P1. And U of P1 comma F comma alpha is greater than or equals to U of P2 comma F comma alpha. And just try to understand this theorem, first theorem, then you can easily go through the further theorems in this unit. And theorem 2, this is the most repeated question for the short answer type, but the answer will be long, but this is the short answer question, most repeated one for the 2 marks. And the necessary and the sufficient condition for the function f to be RS integrable. This is also the repeated one. And sometimes what they mention is they attach the question like prove their properties also. So if they give the question like prove the properties, then whatever the properties you know, then you can write. But if they particularly mention this property, then you need to write those properties conclusion only or proof. So try to learn the properties of RS integral also. And unit step function of all the, try to learn all the definitions so that it might come for the 2 marks questions. Fundamental theorem of integral calculus. This is the long answer type questions. Sometimes they in the question directly mention the prove the fundamental theorem of integral calculus, but sometimes they will give the statement. So you have to be prepared and sure. If they give the statement also, if they give the theorem name also, you should be able to understand the question and write the answers. And that's it from the unit 2. And now let us see in the unit 3, sequence and series of a function. Just try to look at the example problems so that they will be asked for the 2 marks questions. And the uniform convergence theorem from unit 3, this is the long answer type question. So if you understand the concept and the first theorem of uniformly converges, then you can able to understand the further theorems in this unit easily. And this one, Cauchy criterion for uniform convergence of sequence of functions. This theorem is also important, asked for the, maybe expected for the long answer type question. And this is the most repeated theorem, and this has repeated in 2025, 2024, and some of the backlogs also. Uniform convergence and integration. And theorem from uniform convergence and differentiation. The theorem 9. This one, this theorem. Just have a look at Stone-Weierstrass theorem. Mostly it is asked for the mathematics students, but just have an idea what is meant by Stone-Weierstrass theorem. And that's it from my end of the long answer type questions from unit 1, unit 2 and unit 3. Now I'll also show you as a proof that whatever the questions I have shown you, those are repeated in the previous year question papers. As I said, I'll also show you those question papers. Please go through it. And this is the 2025 question paper, mathematical analysis, first paper and semester 1. If you see the first question, compact set. This is the definition. And the second one, monotonic increasing function. If you don't know the answer, just try to write the concept. For example, what here the second question is monotonic increasing function. You don't know the answer. Just try to write the definition of monotonic increasing function. And I have said you to go through the examples for the third unit. This is one of the example. And the fifth question, as I said, this is given for the short answer for the 2 marks, but the answer is so long that we know. But try to don't write each step clearly. Just shortcut the steps and write as a short answer. Fifth question. And in part B, we need to attempt the 5 questions. And this is from unit 1. Show that compact subset of a metric space are closed. And if F is continuous mapping of a compact metric space X into a metric space Y, then show that F is uniformly continuous on X. And state and prove generalized mean value theorem. And the 8th question, this is the necessary and sufficient condition theorem. Sometimes they will give like this, but sometimes they won't give the statement. They give only the theorem name. And this 8th B is a fundamental integral calculus theorem. They have given the statement. And this is from unit 3. This is uniform and differentiation theorem. And the last one, it is from unit 1 only, continuity and connectedness, this theorem. Hope you have understood the questions framing in 2025. Now I also show you 2024 question paper. This is the 2024 question paper, mathematical analysis. And if you see the short answer question, part A, the first question, show that every neighborhood in a metric space is an open set. And the second one, it is repeated in 2024 also. And this third one, the example problem. And fifth one, define a connected set and give an example. And in part P, if E is an open set, then E complement is closed set. Show that every KCL is compact. Anyone you can attempt from 6A or B. You can attempt A or B. And the seventh one, it is necessity and sufficient condition, 7th A. And 8th A, it is continued uniformly and differentiation. This is also repeated in 2025 if you remember. And 9th B also. It is also repeated, this question is repeated in 2025. And if you see 10th B, here directly they have given state and prove the fundamental theorem of calculus. But in 2025 question paper, they mentioned the statement. Hope you have understood how the question papers or question paper pattern is set, or how they are framing the questions. And I'll show you the backlog paper also, recently conducted in 2025. If you see the first question, define a perfect set. And fifth question, define unit step function. And fourth one, give an example of a function which has a discontinuity of the second kind. And if you see the third question, I think so this is the same question which has repeated in 2024 question paper. And the part B, prove that every K cell is compact. And 8th A, state and prove Cauchy criterion for uniform convergence. This is from unit 3, 8th A. And this 9th A, ninth question is of totally unit 1. And 10th, here this is the first theorem, 10th A. And this 10th B is of properties of Riemann-Statigel integral. And this is how the questions are framed. And just if you have any previous year question papers also, please go through it. And all the best, prepare well and write the exams well. And I also show you sometimes what happens is we learn a bundle of theorems, so we forget the proofs, like we confuse, and for one theorem we will write the proof of another theorem. So in order to get rid of this confusion, I'll tell you one trick. I'll show you how to remember the theorems and proofs. And whatever the theorems that you have prepared, once the preparation is completed, just take a paper and pen and write down the theorem statements like this. And after writing the theorem statement, just try to recalculate or re-remember what might be the theorem proof. You'll get some small keywords. Like if we get that key point, then we can prove the whole theorem. So if you get that short, then write here that keyword or that part of small hint. Just try to write here. And do the same for all the theorems that you have learned in a paper, just a short paper. And before going to the examination, just try to have a look at it and see once. Then you will get the whole idea, like, yes, this is the theorem statement. And if you write the hint here, then once if you seen that, then you will get an idea. Oh, the next step is this. The next step is this. Then you can easily prove the total theorem. Then that's it. Then you will never forget the theorem proof. And if you are learning for the examination like 5 days before or 10 days before, just whatever you learned the whole day, just at the end of the day, try to learn or try to remember those. Like have a look at it again. Today you have prepared this one. Then just write, put it in a paper. And just by the end of the day, just go through it. And the next day you are learning something new. And at the end of the day, write those all. Like first day what you have learned, and second day what you have learned, and just once again look into it. Then you will not forget whatever you learned before with the new knowledge. I hope you have understood this one, and if you see this one also, you will like understood. Like theorem 4. If you see, I have wrote the theorem statement, and beside I wrote the key points or hint points to prove this theorem. If I seen this, then I'll get an hint to how to prove the whole theorem, so that I just don't forget it and I just don't confuse with the other theorems also. Hope you have understood how to prepare and how to remember the theorems, and just do it. This is my choice, or this is like how I learned through, and what is the strategy I play to score the good marks. Thank you everyone, and happy learning to you.